Okay, so we're going to begin by drawing heptane. 1, 2, 3, 4. Put a methyl on the 2 position, methyl on the 3 position, add some hydrogens, hit arrange, hit fit, hit roll. Okay, so now we're looking for the chiral center, and that's going to be the one that doesn't have anything attached that is like a duplicate. For instance, here you have 2 hydrogens, 2 hydrogens, 2 hydrogens, 2 methyls. This one you have a hydrogen in the back, you got a methyl right here, you have a butyl, and you have this isopropyl. So this would be the chiral center. Hydrogen has the least priority, so it goes in the back. If your compound is like this, you want to make sure that you move this to the back, because it's going to mess up your results. This methyl can be on either top or bottom. It doesn't matter, you get the same results. I'll show you that right now. And now we're doing the prioritization. So what I figured out is that usually when you have a branch like this, a long branch, compared to a carbon attached to 2 carbons, this is more likely the highest priority, but we're going to count and figure that out right now. So again, this one, methyls are usually the lowest priority besides this hydrogen in the back, so I ignore it, but we'll still count it. You go 1 out, carbon, carbon, carbon. Go 1 more, 3 hydrogens. 1 carbon, 2 hydrogens already beats this one, so we can count this one out. So this was 1 carbon, 2 hydrogens. This was 2 carbons, 1 hydrogen. So 2 carbon, 1 hydrogen beats 1 carbon, 2 hydrogens. So this would be the highest, second, and this one. And we want to turn it around because this is actually our clockwise position. So we press mirror, and that should be it. And let me show you how it is on the methyl if it was on the top. Okay. So again, we have our highest priority, the one with the carbon with 2 carbons attached. That's the one right here. We have our long branch right here and our methyl. So this would still be highest priority, second, third. It would still be going counterclockwise, so that would be S. So let's check that out. Okay. Okay, so first you want to draw a hexane. 1, 2, 3, 4, 5, 6. Draw 2 methyls on the 2 position, a methyl on the 3 position, add your hydrogens, hit arrange, fit, and roll. Okay, so immediately when I see this, I look for the 1 hydrogen that's by itself, because usually that's a tell of which is the chiral center. But let's go through it. You see here, you've got 2 duplicates, 2 hydrogens again, 3 methyls. So that's correct. This is our chiral center. The hydrogen's in the front, so we want to move that. I like leaving my methyl on the bottom. I'm just used to it, so I'm gonna leave it on the bottom, but whatever you're used to, either way, top or bottom, it'll be right. So I see a long branch. I see a carbon attached to 3 carbons. So I'm gonna assume this is the highest priority, but we're gonna go ahead and check that out. This is the lowest because it's 3 hydrogens. When you go 1 bond out, so you go carbon, carbon, 1 carbon, 2 hydrogens. 3 carbons, no hydrogens. 3 carbons is greater than 1 carbon that has 2 hydrogens. So this is the greatest, this is the second, and this is the third. It's going counterclockwise. So we're going to have 2 mirrored. Now we have our highest priority on this side, going to the second, going to the third. Let's see if that's right. Okay. Draw the octane. It's got a methyl on the 4 position, 1, 2, 3, 4. form. Add your hydrogens, arrange, fit, and roll. Okay, so I see this hydrogen already poking out at me. 2 hydrogens here, 2 hydrogens here, 2 hydrogens here, 2 hydrogens right here. So here's my chiral center. I'm going to roll that around, so hydrogens in the back. I like my methyl in the bottom. Okay, so for this one, I look at the longest branch, and the longest branch has the highest priority. So this one's got 3 carbons, this has got 4 carbons. So this is the highest priority, second, third. So it's an S. So these branch ones are easy because you can just compare the length and immediately know which one when dealing with just the same atom of carbon and hydrogen. So let's see if that's right. Right, we got highest, second, third. Counterclockwise, S. Okay. I hope this doesn't just make sense to me. Next. Okay, we're going to enter the name. Of course, I see this hydrogen. I also see this hydrogen. So let's take a closer look. I'm going to zoom in. So this carbon has 2 hydrogens and 2 methyls. This one's got 2 hydrogens. This one's got 2 hydrogens, 2 hydrogens. So here is my chiral center. Again, put the hydrogen in the back. I like my methyl on the bottom. And now I'm going to compare these two. I see 2 hydrogens attached to a carbon. I have 2 carbons attached to a carbon right here. So I'm going to assume that this is greater, but I'm going to go through it just to double check. So this was 3 hydrogens. 1 carbon, 2 hydrogens. 1 carbon, 2 hydrogens. We have to go 1 more bond out. 2 carbons, 1 hydrogen. 1 carbon, 2 hydrogens. So this is the greater one. This would be the second, and this would be third. So let's go ahead and name it. 1, 2, 3, 4, 5, 6, 7. Heptene. We've got methyl right here. We've got a lot of methyls here. Okay, 1, 2. We've got 1 on the 2 position and 1 at the 4 position. So that would make it dimethyl. And you always want to start with the lowest number. That's why I'm going from right to left, because I want the lowest. 2, 3, 4. And then we've established that the one with the carbons with 2 carbons attached is the highest. So 1, second, third. That's going counterclockwise. I'm going to put an S. And let's see if that's right. All right, let's go to the next one. Okay, I'm gonna look for the one. I see 1 hydrogen back here. 2 hydrogens coupled to this one, 2 hydrogens coupled to this one, 2, 2. So, yep, this is it. The hydrogen's already in the back, but I like my methyl in the bottom, so I'm gonna turn this around. And this one's going to be easy because it's the branches. So here's a short branch, here's a long branch. This one's going to have the highest priority. 1, 2, 3, 4, 5, 6, 7. Heptane. And then we do, where's the methyl? Right here, 1, 2, 3 at 3 position. 3 methyl heptane. And then we've established this is the highest, second, third. Counterclockwise is S, and let's see if this is right. Okay, I'll do one more. Methyl hexane. So draw the hexane, methyl at the 3 position, add your hydrogens, hit arrange, fit, and roll. So I already see this hydrogen, of course, by itself, but we're going to double check 2 hydrogens, 2 hydrogens, 2 hydrogens. Turn it around so the hydrogen is in the back and my methyl on the bottom. This one is easy as well because you've got the branches. So we've got highest priority here, second, third. It's going around this way, so we drew R, and we're going to go here, mirror. Now we have the highest priority here with the longest branch, second, third, counterclockwise. Let's check it out. Perfect. I'll do one more, and I'll see if it's hard. Let's see if it gives a hard one. Okay. So I already see my hydrogen here, but I'm still going to count duplicates, methyls. I got my hydrogens here. So this is the chiral center, so I'm going to turn it around so that that hydrogen is in the back. I got my methyl where I like it, and I see the branching right here, so I'm assuming this is going to be the highest, but let's check it out. So we go one out for how we did this, and then we go another one, because you remember carbon, 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 it's the same one, so you go one out again. I will give you 3 hydrogens on the bottom. This would give 3 carbons here, no hydrogens. And this would give 1 carbon, 2 hydrogens. So 3 carbons is greater than 1 carbon and 2 hydrogens. So this would be greatest priority. Let's do the counting. 1, 2, 3, 4, 5, 6. Let's do hexane. We've got 3 methyls. So I'm going to start here. We've got 2 methyls at the 2 position, so 2, 2. And then a methyl at the 3 position. Oops. Make sure to put commas. That would be trimethyl hexane. And then we've established that this is the highest priority, so 1, 2, 3. Counterclockwise, S. Let's double check. 1, 2, 3, 4, 5, 6. 2 methyls at the 2 position. 1 methyl at 3 position. And let's see if that's right. Okay.